Welcome to this traffic segmentation tutorial for 3 internet lines. In this tutorial, I will explain a method that, from my point of view, is much more efficient than traditional load balancing methods, such as PCC, NTH, SMP. In other videos of this course, we have worked with the PCC method, as it is very stable. But when implementing PCC, we are subject to the MikroTik algorithm, meaning we don't have control, nor can we define which connection goes out through which WAN interface. The work of this algorithm, while good, is not the best, as there are many processes the MikroTik must perform before focusing the decision to take a connection and route it through any of our providers or WAN links. The working method we will apply next consists of routing clients directly to the WAN connection that we consider appropriate. We will simply make a route mark in the Mangle for each WAN connection we have, and then use that mark to create the necessary routes. Really, this method demands fewer tasks from a MikroTik and has very high effectiveness, as it allows clients to have much smoother and faster navigation. It also allows exploiting or squeezing the maximum bandwidth from my contracted internet providers. The first thing we're going to do is log into our MikroTik. We open the new terminal and type system reset configuration no equals yes. Press enter and it asks for confirmation yes. Click on cancel. Very well, let's go back to the neighbor tab. Click on the refresh button. I select the MAC address, login, admin, password blank. Click on connect. I close this new terminal window and we now have our MikroTik clean. Let's go to our working diagram. Here we have provider A with IP address 192.168.100.1, provider B with IP address 192.168.200.1, and provider C with IP address 192.168.250.1. Note that the IP address ranges of the provider's networks must be different. The provider's routers will be connected via a network cable to the MikroTik. The IP addresses will maintain a consecutive order. For provider A, 192.168.100.1, and the MikroTik port receiving this connection will have 192.168.100.2. For provider B, 192.168.200.1, and the MikroTik port receiving this connection will have 192.168.200.2. Finally, we have provider C, 192.168.250.1, and the MikroTik port receiving this connection will have 192.168.250.2. And on the MikroTik's LAN port, we will have the IP address 172.168.1.1, and the computer we connect to the LAN port will have 172.168.1.2. If you follow these 7 basic steps, you will have your segmentation operating correctly. Step 1. Naming the interfaces. Here you must identify the interfaces you're going to use. Log into Winbox. Interface type. Double-click on Ether1. Name WN1. Comment Ether1. Ether2. Name WAN2. Comment Ether2. Ether3. Name WAN3. Comment Ether3. Ether5. Name LAN. Comment Ether5. OK, apply, and OK. Step 2. Configuring the IP addresses on each interface. We're going to assign the IP addresses to the interfaces WAN1, WAN2, and WAN3. We will also do it for the LAN interface. Go to IP, Addresses, click on the plus sign. Select Interface WAN1. Address 192.168.100.2/24, just as it is in our guide. Again, click on the plus sign. Interface WAN2, address 192.168.200.2/24. Again, click on the plus sign. Interface WAN3, address 192.168.250.2/24. Lastly, click on the plus sign. Interface LAN, address 172.168.1.1/16. Good. We have now assigned the IP addresses to the interfaces WAN1, WAN2, WAN3, and LAN. Close this window. Step 3. Masquerading the WAN interfaces. This means we must NAT the WAN1, WAN2, and WAN3 interfaces. Go to IP Firewall. NAT tab. Click on the plus sign. Here within the General tab, change CircNAT. Out interface WAN1. In the Action tab, select Masquerade. The same procedure for WAN2. Change CircNAT. Out interface WAN2. Action Masquerade. Repeat the procedure for the WAN3 interface. Chain SRC NAT. Out interface. WAN3 Action Masquerade. Observe, there we have our 3 WAN interfaces with NAT. Close the window and continue. Step 4. Creating the routes. We're going to create static routes for WAN1 with IP address 192.168.100, one with distance 1. And for WAN2, with IP address 192.168.200.1 with distance 2. And also for WAN3, with IP address 192.168.250.1 with distance 3. For this, go to IP routes. Plus sign. Gateway 192.168.100.1 check Gateway, ping distance 1. Again, plus sign. Gateway 192.168.200.1 check. Gateway, ping distance 2. Again, plus sign. Gateway 192.168.250.1 check. Gateway, ping distance 3. Very well, observe what happened. We now have 3 routes, one for WAN 1 with distance 1, and a route for WAN 2 with distance 2. Similarly, we have a route for WAN 3 with distance 3. The routes for WAN 2 and WAN 3 turn blue. What does this mean? It means that the routes are created correctly, but they're not active. That is, they're waiting for the route with the lower distance, the one with distance 1, for example, to fail to then start working or become active, the next route with distance 2. Similarly, the route with distance 3 is waiting for the route with distance 2 to fail for it to start operating. However, the logic of this method will come into play with the routes we will create a few steps later. Let's continue with step 5, creating the IP address list for our clients and the route marks. What we're going to do here is very simple. We will create an address list named 1. And what we will do is link that list with route mark A. We will also create list 2, which will be linked to route mark B. And finally, we will create list 3, which will be linked with route mark C. The order in which we will work will be the following. First, we will create the address lists 1, 2, and 3. And then in the Mangle, we will create the route marks A, B, and C. Let's start. Go to IP firewall address list. Click on the plus sign. In name, type 1. This will be the name of our list. In the address section, it will remain 0.0.0.0. Let's create the second list again. Click on the plus sign. Name 2. Address will remain 0.0.0.0. Now we will create the third list. Click on the plus sign. Name 3 and in address, leave it as is. We already have lists 1, 2, and 3 on the screen. In this arrow on the right, we can also find these lists. This section is useful for filtering IP addresses, meaning if I want to see only those from a specific list, for example, those from list 1, or list 2, or list 3 individually. Very well. Now let's go to the Mangle to create our route marks and link each mark with the address list we just created. Click on the plus sign. Go to the General tab, Chain Pre-routing, Advanced tab. SRC address list. Here the lists we created a moment ago appear, 1, 2, and 3. Select List 1. In the Action tab, select Mark Routing. And in new routing mark it as A and uncheck pass-through. Continue with the next rule. Click on the plus sign. Chain pre-routing in the Advanced tab in SRC address list. Select List 2 and in the Action tab. Mark routing, uncheck pass-through, and in new routing mark, type B. Let's add the last route mark. Click on the plus sign, General tab, Chain pre-routing in the Advanced tab in SRC address list. Select List 3 and in the Action tab. Mark routing, uncheck pass-through, and in new routing mark, type C. Observe, now we have the route marks A, B, and C. Here, in this way, we have finished step 5. Now, I'm going to explain with a detailed graph what we are going to do during steps 6 and 7 of this course. Observe, this is the network topology we have been working with. I just added the orange circle representing our internet provider's network, and also added the public NS servers of Google and also those of OpenDNS. I do this to have a much more generalized overview of the work we are going to perform. If we focus on our MikroTik and analyze the case of provider, we find that the gateway would be the IP address 192.168.100.1. Indeed, I cannot rely on this address to assert that I have internet access through that provider, as it will be enough for that router to be turned on for that address to respond to ping from the MikroTik. But if the provider has a failure in their network, meaning that provider is not actually providing internet access at that moment, and the mistake is made of implementing the entire MikroTik configuration, telling it that if the gateway address 192.168.100.1 responds to ping or is reachable, then it should continue throwing client traffic through there. The result will be fatal, as the end client will have no navigation when the provider's network fails, and at that moment the problems, calls, and dissatisfaction from the clients on our network begin. Hence, it is necessary to perform a failover with recursive routes. The problem of having redundancy and high availability in the internet service we provide to our clients. We will solve it with a simple failover using recursive routes. What we will do is create a route, specifying that through the internet provider's gateway, a public DNS must be reached. In this case, we will use Google's DNS and also OpenDNS's using Scope 10. Subsequently, we will create the corresponding routes using the aforementioned public DNS as gateway. Since it is possible to specify the gateway to a network, even if this gateway cannot be reached directly. Let's take provider A as an example. The gateway is 192.168.1001. I can create a route in our MikroTik telling it to reach Google's DNS 8 at 8.4.4. Through gateway 192.168.100.1 with scope 10. Subsequently, I can create another route specifying DNS 8.8.8.8 as gateway. Although it's true I cannot reach it directly, I can use provider B's IP address as a bridge. The same procedure must be carried out for provider C. Let's start with the development of Step 6, creating recursive routes using public DNS. In this step, what we're going to do is very simple. Create 3 routes, each pointing towards the corresponding provider's router, and we will tell it to reach a public DNS. For example, the first route indicates reaching Google's public DNS 8.8.4.4 IP address 192.168.100.1. The second route indicates reaching the public DNS 8.8.8 through the provider with IP address 192.168.200.1. And the third route indicates reaching OpenDNS's public DNS 208.67.220.220 through the provider with IP address 192.168.250.1. It is important to note that all routes must have the scope set to 10. Let's start. Go to IP routes +. In DST address type 8.8.4.4 gateway 192.168.100.1. Check gateway ping, although it's not in the guide. I can also check it without any problem. Distance 1, scope 10, target scope 10. Again, +, DST address 8.8.8. Gateway 192.168.200.1. Check gateway, ping. Distance 1. Scope 10. Target scope 10. Lastly, +, DST address 208.67.220.220. Gateway 192.168.250.1. Check gateway, ping. Distance 1. Scope 10, target scope 10. Observe, here we have highlighted the 3 routes we just created. And let's continue with step 7. We will create the routes according to the mark and also the failover using recursive routes. Now what we will do is create 3 routes for mark A, each pointing to the DNS servers we have been working with, using distances 1, 2, and 3. Similarly, we will create 3 routes for mark B, pointing to the corresponding DNS servers we have been working with, using distances 1, 2, and 3. And finally, the procedure is repeated for mark C. Well, now let's start with the 3 routes for the brand A. Return to IP routes, +, gateway 8.8.4.4, which is the DNS we use for our provider A. Check gateway ping. Distance 1. Routing mark A. Now, following our guide, we're going to create the second route with mark A, but with distance 2, taking the DNS used for provider B as the gateway. This is so that if the route with distance 1 fails, then this route we are creating will come into action, meaning it will become active and pick up all that traffic that provider A had and route it automatically through provider B. Again, plus sign. Gateway 8.8.8.8, which is the DNS we use for our provider B. Check gateway ping. Distance 2. Routing mark A. In case provider B also fails, then we will create a third route with mark A, with distance 3, taking the DNS used for provider C as the gateway. This is so that if the route with distance 2 fails, then this route we are creating will come into action, meaning it will become active and pick up all this traffic that provider A had and that provider B took over. But after this provider also stopped operating due to some technical failure, the MikroTik will automatically route all this traffic through provider C. Again, plus sign. Gateway 208.67.220.220, which is the DNS we use for our provider C. Check gateway ping. Distance 3, routing mark A. Continue with the 3 routes for mark B. Plus sign, gateway 8.8.8.8, which is the DNS we use for our provider B. Check gateway ping. Distance 1, routing mark B. Now, following our guide, we're going to create the second route with mark B, but with distance 2, taking the DNS used for provider A as the gateway. This is so that if the route with distance 1 fails, then this route we are creating will come into action, meaning it will become active and pick up all that traffic that provider B had and route it automatically through provider A. Plus sign, gateway 8.8.4.4, which is the DNS we use for our provider A. Check gateway ping. Distance 2, routing mark B. In case provider A also fails, then we will create a third route with mark B with distance 3. Taking the DNS used for provider C as the gateway. This is so that if the route with distance 2 fails, then this route we are creating will come into action, meaning it will become active and pick up all that traffic that provider B initially had and that provider A took over. But after this provider also stopped operating due to some technical failure, the MikroTik will route all that traffic automatically now towards provider C. Again, plus sign, gateway 208.67.220.220, which is the DNS we use for our provider C. Check gateway ping, distance 3, routing mark B. Now let's make the 3 routes for mark C. Plus sign, gateway 208.67.220.220, which is the DNS we use for our provider C. Check gateway ping, distance 1, routing mark C. Now, following our guide, we're going to create the second route with mark C, but with distance 2, taking the DNS used for provider A as the gateway. This is so that if the route with distance 1 fails, then this route we are creating will come into action, meaning it will become active and pick up all that traffic that provider C had and route it automatically through provider A. Plus sign gateway 8.8.4.4, which is the DNS we use for our provider A. Check gateway ping distance 2, routing mark C. Click on apply and OK. In case provider A also fails, then we will create a third route with mark C with distance 3. Taking the DNS used for provider B as the gateway. This is so that if the route with distance 2 fails, then this route we are creating will come into action, meaning it will become active and pick up all that traffic that provider C initially had, and that provider A took over. But after this provider also stopped operating due to some technical failure, then the MikroTik will automatically route all this traffic through provider B. Plus sign gateway 8.8.8.8, which is the DNS we use for our provider B. Check gateway ping distance 3, routing mark C. Very well, close this window. We have now finished the configuration phase and will begin testing. Go to Interfaces. According to our network diagram, my computer should be connected to the LAN port with the following IP address: 172.168.1.2, netmask 255.255.0.0, and the gateway 172.168.1.1. I'm going to configure it now. IP address 172.168.1.2 and the gateway 172.168.1.1. Netmask 255.255.0.0. Very well. After having our IP address configured on the PC, go to IP firewall address list, and here we find lists 1, 2, and 3. I go to the arrow and choose list 3. And this address 0.0.0.0, which was created by default, we're going to change it to our PC's IP address, which is 172.168.1.2. We go to the Mangle rules and observe how the rule containing list 3 started to show packet movement. Observe here in SRC address list, it is linked to list 3 with route mark C. I go to IP routes, and here I can identify that route mark C has WAN 3 or provider C as its output. Observe the WAN interfaces. There is no traffic at this moment. When I start generating traffic, it should exit through WAN 3. I'm going to run a speed test. Observe, there we have 16 megabits per second download over WAN 3, and approximately 1 megabit per second upload. Very well. Now I return to the address list, and I'm going to modify this rule so that my PC's IP address 172.168.1.2 is now routed through WAN 2. Simply here in name select 2, apply, and OK. Observe that now nothing appears in list 3. I'm going to filter list 2 here, and here are 2 items. One of them is the default 0.0.0.0. I select it and click the minus sign to delete it, and only our PC's item remains. Let's go to the Mangle and observe how the rule containing list 2 started to show packet movement. Observe here in SRC address list, it is linked to list 2 with route mark B. I go to IP routes, and here I can identify that route mark B has WAN 2 as its output, or equivalently, provider B. I'm going to run a speed test. Observe that we have approximately 16 megabits per second download over WAN 2. And approximately 1 megabit per second upload. Now I return again to the address list, and I'm going to modify this rule so that my PC's IP address 172.168.1.2 is now routed through WAN 1. Simply here in name, select 1. Observe that now nothing appears in list 2. I'm going to filter list 1 here, and here are 2 items. One of them is the default 0.0.0.0. I select them and click the minus sign, since I'm not using this IP address for anything. So I select it and click the minus sign to delete it, and only our PC's item remains. Let's go to the Mangle and observe how the rule containing list 1 also started to show packet movement. Observe, here in SRC address list, it is linked to list 1 with route mark A. I go to IP routes, and here I can identify that route mark A has WAN 1 or provider A as its output. From interfaces, let's run a speed test to now see the traffic on WAN 1. Observe between 47 and 48 megas approximately download, and the upload is between 5 and 6 megas approximately. With this, what we want to prove is that you can route clients through the provider you consider necessary, through provider A, provider B, or provider C. Now let's test the failover theme. Currently, our PC is routed through WAN 1, which has approximately 48 megas download. What would happen if this provider A, or equivalently, the WAN had a failure? The answer to this question is found in IP routes. Observe, here we have 3 routes with mark A. The route with mark A has distance 1. The route with mark A has distance 2. So, if the route with distance 1 fails, the route with distance 2 will start operating. We run the speed test again, and traffic is exiting through WAN 1 since we're routed there. Now I'm going to disable the WAN 1 interface to simulate a possible failure. Note that the client with the computer still has internet access. Since MikroTik routed all the traffic now through WAN 2. Let's return to IP routes, now that our WAN 1 is out of service. Observe that now the route that had distance 2 is now black and says as. This means that this route is active. In other words, all the traffic that WAN 1 or provider A had was automatically taken over now by WAN 2 or provider B. Let's activate WAN 1 again. And observe how the route with distance 1 becomes active again, while the route that was replacing it returned to its usual condition in blue, meaning it stopped being active to be in standby mode, so to speak. Let's generate traffic once more. And observe how this traffic goes out through WAN 1. Very well. Now let's test the failover for WAN 2 or equivalently for provider B. Go to IP firewall, address list. Tell the MikroTik that our PC should now go out through WAN 2. Apply and OK. Filter the clients from list 2 and go to interfaces. Also, let's generate traffic. And observe that this traffic is going out through WAN 2. Upon deactivating WAN 2, observe how the route with mark B with distance 2 turns black and its status is active. In other words, all the traffic that WAN 2 or provider B had was automatically taken over now by WAN 1 or provider A. I'm going to run a speed test. Let's activate WAN 2 again. And observe how the route with distance 1 becomes active again, while the route that was replacing it returned to its usual condition in blue, meaning it stopped being active to be in standby mode. Let's generate traffic once more. and observe how this traffic goes out through WAN 2. Lastly, let's test the failover for WAN 3 or provider C. Go to IP firewall address list, and I will move my PC's IP address from list 2 to list 3. Apply and OK. Again, we generate traffic and observe the saturation on WAN 3. Now let's deactivate WAN 3. Observe that we continue with internet because the route with distance 2 was activated, that is the WAN 1 route. Let's also deactivate WAN 1 and observe that we continue browsing now through the only WAN that is active, that is WAN 2. In this way, we find or can conclude that this configuration method is very stable as it provides redundancy across all our links, and our clients will always be active. Now I'm going to activate WAN 1 and WAN 3 to restore our internet links. Very well. So far we have tested that we can route our clients through the WAN connection we desire. And we also tested the failover, finding that if any provider through which I have my clients routed fails, the MikroTik simply automatically will throw that traffic to the provider with distance 2. And if that provider also fails, then the traffic will be taken over by the provider with distance 3. Once the provider's internet services recover, everything returns to normal and the traffic continues its course through where it was initially routed. Now I would like to show you this configuration in a real environment, meaning I'm going to disconnect my PC from the LAN port and connect all my clients there to know their IP addresses. I go to IP neighbors. After identifying the client's IP addresses, I will start moving them over little by little. I will start by routing the IP address 172.168.1.7 through list 3. Then the client with IP address 172.168.1.9. Return to IP neighbors. To see more clients, continue now with IP address 172.168.1.14. Again in neighbors. Next is IP address 172.168.1.18. Very well, here I will continue adding the clients manually little by little. I will try to distribute them across address lists 1, 2, and 3, and I'm going to advance or speed up the video a bit so it doesn't become too long. Very well, observe, I already have my clients included in the address list. 3, 2, in one. Here, within interfaces, I know I have WAN1 with a speed of 48 megas, WAN2 with a speed of 15 megas, and WAN3 also with 15 megas. We can observe here WAN2 with a very low traffic level. So I'm going to move clients from WAN3, which is saturated according to its capacity, towards WAN2. For this, it's very simple. Go to IP, firewall, address list. Change the number 3 to the number 2. And in this way, I organize my clients according to the capacity of my WAN connections. Now, if you want to do bandwidth management, it's very simple. You can go to queues, +, name client 1, for example. Target 172.168.1.2 upload speed 1 mega and download 3 megas. Apply and OK. In this way, you can do it with each of your clients. Observe the LAN interface oscillating between 60 and 70 megas. And something I like very much is that the CPU consumption of our MikroTik equipment is very low. In this way, we have configured 3 WAN connections on the same device with failover and also managing a good number of clients. Well, I only created one bandwidth restriction via simple queue as an example, but you should configure restrictions for each of your clients. Truly, this configuration method is much more effective than traditional load balancing methods, as it consumes fewer CPU and memory resources from the MikroTik router. And also navigation is much smoother with these segmentations than with the PCC method. Another great advantage is that it allows us to squeeze the maximum bandwidth we pay our provider for. If I have a dedicated internet channel, for example, I can route the clients who pay me better through there. And those who pay less I can route through a cheaper provider or one that is a channel with shared use. Meaning, we have control of the network and are not subject to the PCC algorithm. Now to finish, I want to add one last rule here in the Mangle section. This rule will ensure that you do not lose management of the devices on your LAN network. I mean that if you want to access the configuration of one of the routers on your LAN network, one of your radios, one of your ONUs, well, that it is possible for you to do this without any type of inconvenience. And for this to work, we need to add the following rule. I am going to click here on the plus sign. And in the General tab chain, pre-routing and SRC address, I am going to type the address of my LAN network, the network address. In this case, it is 172.168.0.0/16. I'm going to copy it. And I'm also going to paste it here where it says DST address. What does this mean? That if something comes from this source, meaning if it leaves the LAN network and is also directed towards the LAN network, that traffic will be accepted. I'm going to click Apply and OK here, and it will not be processed within these route marks that we had configured previously. So, for it to take effect, I'm going to drag that rule and leave it above, in such a way that it is rule number 0, the one that will allow me not to lose management of the devices on my LAN network. Very well, friends. I think this has been the end of this video. I hope it has been to your liking, that you apply it. Surely all this valuable content will bring benefits to your network and your business. See you in a future video tutorial.